Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this lecture we'll be studying the GSM channels that are used for communication. Remember, there are two types of channels being used, that is traffic channel and control channels. We'll be studying various types of them in this lecture. GSM channels. Let us first understand what are the frequency bands being allocated for the GSM channel. The uplink frequency channel is located from 890 to 915 MHz. The downlink frequency spectrum in the GSM band is allocated from 935 to 960 MHz. If we remember the frequency division duplexing, then we can understand that there is a considerable frequency gap between the uplink channels and the downlink channels. The initial part of the GSM uplink frequency starts from 890 MHz, whereas the downlink starts from 935 MHz. If we see, there is a considerable 45 MHz of guard band or a 45 MHz of band gap that has been provided, because both the frequencies should be well separated so that there is no interference during the communication. Frequency division duplexing gives us an exact scenario where the forward link channel and the reverse link channel are considerably separated. Here, the entire bandwidth of the uplink channel and the downlink channel is separated with 45 MHz of band gap. Every channel in GSM has a bandwidth of 200 kHz. And there is 100 kHz of guard band which has been given at the upper side and the lower side of the entire frequency spectrum. Now, if we calculate the number of channels that the GSM system supports, it is very simple. 25 MHz, that is the uplink frequency, which starts from 890 to 915 MHz, which is nothing but 25 MHz. That 25 MHz, we will subtract 200 kHz, that is 100 kHz of guard band at the lower end and 100 kHz of the guard band at the upper end, divided by the individual channel frequency of the GSM, which is nothing but 200 kHz. In this calculation, the final answer that we'll receive is 124 channels are available for GSM communication. 124 for uplink and 124 for downlink. So in all together, we have 124 duplex channels available in GSM for communication. Duplex, as we know, is nothing but a two-way communication in which a user is simultaneously transmitting and receiving the information. In GSM, as we know, every user is divided in time slots. There are 8 time slots per channel in the GSM system. Every channel in the frequency domain, that is, we calculated as 124 duplex channels are available. So every channel has a ARFCN number, which is called as absolute radio frequency channel number. Every ARFCN channel number is divided into 8 time slots for 8 different users. Hence, one single physical channel is represented by one ARFCN number along with the time slot. All the 8 time slot users on the same channel have same ARFCN number, which is the absolute radio frequency channel number. As we know, in GSM we have two types of channel. One is called as a traffic channel, the other is called as a controlling channel or the signaling channel. 95% of the entire spectrum is allocated for the traffic channel, that is voice and data, and 5% is allocated for controlling or signaling. Let us see all the types of various channels that have been available in the GSM system. In traffic channels, we have got voice channels and data channels. In this, we have full rate data channels and we have half rate data channels. The control channel in GSM are of 3 types. The first type is called as broadcast channel. This channel has got 3 types of channel called as frequency correction channel, synchronization channel, broadcast control channel. The second type of the GSM channel is called as common control channel. It has got 3 types of channel called as paging channel, random access channel, and access grant channel. The third type of GSM channels or control channels are called as dedicated control channels. It also has three types of channel. The first one is called as standalone dedicated channel, slow associated dedicated channel, and fast associated dedicated channel. These channels together form the controlling channels of the entire GSM system. Let us first talk about the traffic channels. In traffic channels, we have got full rate traffic channels and half rate traffic channels. In full rate traffic channels, the user data is given in every time slot of every frame in the GSM structure. If the half rate traffic channels are used, then the user data is given in the time slot of alternate frames in the GSM system. Let us first talk about the speech channels in the GSM system. In GSM, since we are using TDMA, which is time division multiple access, for transmitting the information, it is very clear that the user information needs to be digital, because TDMA uses buffer and burst method for the data to get transmitted. Hence, the user information in the full rate speech channel is first converted into a digital signal at the rate of 13 kbps or kilobits per second, and then by using the channel coding of the GSM system, it is converted into 22 kbps of the data and then transmitted. Similarly, if you are using half rate speech channels, then the raw data of the user is converted into 6.5 kbps and then transmitted by using channel coding at 11.4 kbps. Let us now talk about the data channels. The full rate data channels are three types, where the raw user data is in the range of 900 bits per second, 4800 bits per second, and 2400 bits per second. All this data in full rate get converted with channel coding into 22.8 kbps and then it is transmitted. Similarly, the half rate data channels, in which the user data is in the range of 4800 bits per second and 2400 bits per second, is converted using channel coding in the range of 11.4 kbps and then transmitted for half rate data channels. In this way, we have various traffic channels, which are nothing but the speech and the data channels, which get converted into varying data rates of full rate data channels and half rate data channels, or full rate speech channels and half rate speech channels, and then are transmitted using the communication medium. Hence, the speech channels and data channels are transmitted for wireless communication. Let us talk about the first kind of the control channel, which is nothing but the broadcast control channel. The broadcast control channel has a specific ARF-CN number on which it transmits. It transmits the data on the TS0 time slot of the TDMA GSM frame structure. This broadcast control channel is used for identification of the power levels from the nearby base station, so that the mobile can make the handoff decision using MAHO, also known as mobile assisted handoff techniques. The broadcast control channel serves as a beacon for the nearby phones to lock on to. Means the mobile phone always is searching for the communication channel on which it is going to receive the information for call to be received. Hence, this broadcast control channel serves as a beacon on which every mobile phone is logged on to. The broadcast channel is also used for synchronization of all the mobile phones in the area. Talking about the first kind of the broadcast channel, which is called as broadcast control channel or BCCH. This channel is used for identification of the various channels that are being used in the cell currently. It gives us a list of channels that are currently working or active in the entire cell. Let us talk about the first type of the broadcast channel, that is nothing but the broadcast control channel. It is a forward link channel, which means it is a channel from the base station to the mobile station. The broadcast control channel is used to broadcast the following information like cell and network identity, so that if the user is in any location, the mobile phone knows the identity of the cell in which he is roaming. The second type of the information that the broadcast channel will broadcast is a channel availability information, the congestion information, and also the control channel structure. It is also used to list out the various control channels in the cell. The second type of the broadcast channel is nothing but the frequency correction control channel, which is a very important channel for correction of the frequency. This special burst is sent on the time 0 slot of the first TDMA GSM frame structure, which is the frame 0 of the entire system. This frame is repeated, or this time slot is repeated on every 10 frames in the GSM structure. This GSM channel allows every subscriber unit to set up the frequency of its local oscillator depending on the instructions being received. That is, it is used for synchronization of the frequency of the mobile phone handset on the particular channel at which the mobile phone is communicating. This channel stands out important because mobile communication is a wireless communication system, and hence the data that is transmitted at certain frequency is received on the other side at the same frequency. Because we have strict bandpass filters which allow certain information and restrict the other information, hence maintaining the frequency of the data for transmission in this wireless medium is very important. The local oscillators are inside the mobile phones which set the frequency of the transmission via antennas. So this frequency correction control channel helps set the frequency of the local oscillator exactly to the frequency of the base station at which the mobile phone is communicating. Let us talk about the third type of the broadcast channel, which is nothing but the synchronization channel. The data on the synchronization channel is sent on the time 0 time slot of the frame that is followed after the frequency correction control channel. Since the frequency correction control channel is sent on 1 frame per 10 frames, similarly the synchronization channel is also sent on 1 frame per 10 frames. Hence it is sent once in the 10 frames. This synchronization channel helps identify the serving base station in order to frame synchronize the mobile station to the base station. Frame synchronization is very important since we are using wireless communication and there are multiple paths on which the user data gets transmitted. Because of the delays on the multipath propagation, it is obviously that the frame synchronization should be strict enough in such a way that no data is lost. Hence, synchronization channel helps us synchronize this information. Coming to the second type of the control channel, that are nothing but the common control channels which are used for transmission of other signaling information. These common control channels transmit the data on the TS0 time slot of the GSM frame structure, which is not being used by the broadcast control channels or broadcast channels and the idle frame structure. The control channels or the common control channels are of 3 types. The first one is the paging channel, which is a forward link channel. Means it is from the base station to the mobile station used for paging. The second one is a random access channel, which is a reverse link channel which is used from the mobile station to the base station. The third type of the channel is the access grant channel, which is on the forward link, means from the base station to the mobile station. The first type of the common control channel is nothing but the paging channel. This paging channel is a forward link channel, which means it is from the base station to the mobile station. The paging channel is used to page various information, of which the first information and the important information that it pages is the call originating information to all the mobile stations in the cell. It basically gives the information of the IMSI number on which the call is going to come. It also sends an information for the request of acknowledgement on the random access channel in the mobile systems. And the last information that the paging channel are used to page is nothing but the data in all the cells. So the data information is also paged by this mobile phones, or that is the text messages are also been paged using this channel on all the phones. The second type of the common control channel that we have is random access channel. This random access channel is a reverse link channel, means it is from the mobile station to the base station. Remember, the paging channel, that was a forward link channel on which the user was getting the initiating information about the call with the IMSI number. The mobile has now identified the IMSI number on the page that it has received, and it is knowing that it is going to receive a call. Hence, the mobile phone on this random access channel, that is on the reverse link, will send an acknowledgement for the call that it is receiving. Also, the call origination starts from this channel. Once the base station knows that the mobile phone is ready to accept a call, since we have sent an acknowledgement on the reverse link channel, that is from the mobile station to the base station, that is on the random access channel. The third type of channel that we have is called as the access grant channel. On this access grant channel, that is a forward link channel from the base station to the mobile station, the base station will send a response to the random access channel that we had sent in the reverse link, which was from the mobile station to the base station. Remember, on this random access channel, that is from the mobile station to the base station, we had responded that we are ready for the call. Hence, on the forward channel, that is the access grant channel, now the base station will send the exact channel, that is the time slot and the ARFCN number, which is the absolute radio frequency channel number on which the user is given the time slot to talk. Also, a particular dedicated control channel is provided for controlling purposes. In this way, forward and reverse link control channels are used to set up a call. Coming to the third type of the control channel, that is called as a dedicated control channel. These dedicated control channels are bidirectional, meaning they are from the base station to the mobile station and mobile station to the base station. These channels are used to carry important information for controlling purposes. These channels occur in any time slot, that is TS0, except the time slot that has been used for the broadcast channel in the frame. We have three types of dedicated control channels. The first one is standalone dedicated control channel, slow associated control channel, and fast associated control channel. The first type of the dedicated control channel is nothing but the standalone dedicated control channel. This control channel is used for informations like it is used to send authentication and alert messages when the mobile is synchronizing itself or frame synchronizing itself with the base station, and it is waiting for the traffic channel TCH to originate. In mobile communication, when the user is frame synchronizing and waiting for the traffic channel, there are other functions like authentication which needs to be performed. Authentication helps the GSM system identify whether the user is a valid user or not. Hence, we are sending these messages on the standalone dedicated control channel. Also, alert messages like ringing of the phone is also sent on the standalone dedicated control channel for the mobile to identify that it has received a call. This standalone dedicated control channel may have their own physical control channel on which they can transmit the information, or they can also occupy the TS0 time slot in the TDMA GSM frame structure of the broadcast channels when the demand for the broadcast channel is low. In this way, standalone dedicated control channel helps identify the authentication and sending the alert messages. The second kind of the control channel, that is the dedicated control channel that we have, is slow associated control channel. This channel is always in association with the traffic channel and the standalone dedicated control channels. On the forward link, this control channel is helping in transmitting the user information that is slowly changing, like power level information. It also gives certain advanced information regarding the power. That is, say if the user is moving away from the base station, then the power level are constantly decreasing. Hence, the requirement of a handoff may occur. Hence, this low associated control channel helps the base station identify such users. On the reverse link, that is from the mobile station to the base station, it helps identify the received signal strength indicator value, that is the power levels of the signal. Also, on the reverse channel, it helps identify the signal levels of the broadcast measurements from the neighboring station. In such a way, we are able to identify whether the power levels of the neighboring base stations are going above the power levels of the current base station, which may occur when the handoff scenario comes into picture. The third type of the dedicated control channel is called as fast associated control channel. This control channel is used to send urgent messages like handoffs that occur. Handoff situations are not priorly known, they occur very instantly. Hence, fast associated channel are used where there is no dedicated control channel or slow associated dedicated control channel in the scenario. It is assigned to only traffic channel and it relies on frame stealing. Frame stealing means since it is fast associated and does not have a initial dedicated control channel been given, what it does, it depends on the frame stealing to send the information of handoff, which is immediate. In this way, it is able to gain the access of the traffic channel and send the user information. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.